Welcome, beginner game developers, to an in-depth tutorial on the command game pattern, a powerful behavioral design pattern essential for robust game architecture. The command pattern encapsulates a request as an object, thereby allowing for parameterizing clients with different requests, queuing or logging requests, and supporting undoable operations. It effectively separates the logic for a command or request from the logic that actually executes it, promoting a cleaner, more modular code. This decoupling reduces the dependencies between objects, making your game systems more flexible and easier to maintain. Let's break down the core components of this pattern, starting with the command interface itself. The command declares an interface for executing an operation, typically including an execute method, and often an undo method for reversibility. Next, the concrete command defines a binding between a receiver object and an action, implementing execute by invoking operations on the receiver. The client is responsible for creating concrete command objects and setting a receiver for the command, essentially configuring the specific action. The invoker asks the command to carry out its request without knowing the command's specifics. It simply makes the call to execute. Finally, the receiver knows how to perform the actual operations associated with carrying out the request, containing the core logic of the action. Understanding these components reveals the significant benefits of adopting the command pattern in your game development. One major advantage is decoupling. It separates the object initiating the request from the object performing it, reducing tight coupling between the sender and receiver. This pattern offers immense flexibility and extensibility, allowing you to easily add new commands without affecting existing game logic or requiring modifications to the invoker. Crucially, the command pattern is ideal for implementing robust undo, redo functionality in a clean and maintainable way, enhancing player experience. It also facilitates queuing operations and logging changes, which is vital for complex game systems, debugging, and even network synchronization. For cross-platform compatibility, it separates the action from the input mode, enabling flexible mapping across different devices and control schemes. In multiplayer games, you can share command types in that order, ensuring consistent outcomes across all game instances without sending complex state data. Now, let's dive into the practical implementation of the command pattern in Unity 3D and C#, building a simple movement system. First, we define the iCommand interface, which will include execute and undo methods to handle actions and their reversals. This interface ensures all concrete commands adhere to a common structure, making them interchangeable. Next, we create a concrete command class, move command, which implements our iCommand interface. The move command constructor takes the game object to move, the vector 3 movement amount, and stores the entity's initial position for undoing. Its execute method applies the stored movement to the entity's transfer, causing it to move in game mode. The undo method, conversely, reverts the entity's position to its underscore initial position, effectively undoing the movement. Now, we implement the invoker, our command manager, which will be a mono behavior in Unity. This manager will hold two stacks, underscore undo stack for executed commands and underscore redo stack for undone commands. The execute command method takes an iCommand, calls its execute method, pushes it onto the undo stack, and clears the redo stack. When undo command is called, it pops a command from the undo stack, calls its undo method, and then pushes it onto the redo stack. Conversely, redo command pops from the redo stack, calls execute on it, and pushes it back onto the undo stack. This robust command manager provides a centralized way to manage all game actions, including their history. Next, we create receiver classes, like player mover, which contain the actual logic for performing the actions. The player mover simply has a move method that translates and is transformed by a given direction. This player mover is the object that truly knows how to perform the movement operation. Finally, the client, our player controller, creates concrete command objects and passes them to the invoker. In its start method, the player controller gets references to the command manager and player mover components. The update method continuously checks for horizontal and vertical input from the player. If there's movement input, a new move command is created, encapsulating the game object and the calculated movement vector. This move command is then passed to the underscore command execute command method, triggering the movement. Pressing Z triggers the underscore command manager undo command, reverting the last action. Similarly, pressing X calls underscore command manager redo command, reapplying the previously undone action. This complete player controller demonstrates how the client interacts with the invoker to manage player actions. The command pattern shines in various use scenarios, offering elegant solutions to common development challenges. In real-time strategy games, you can easily queue up unit and building actions, providing players with precise control over complex sequences. For turn-based strategy games, store unit moves or actions in a queue and execute them all at the end of the turn, ensuring fairness. Puzzle games greatly benefit from the command pattern for implementing robust undo and redo actions, crucial for player experimentation and problem solving. In fighting games, reading button presses or gamepad motions in specific command words can result in complex combos and special moves, enhancing gameplay depth. For multiplayer games, it's excellent for creating a messaging system between the server and clients, ensuring synchronized gameplay and reducing latency. To maximize your understanding and application of the command pattern, consider these helpful tips and best practices. Remember the gang of four origin of the command pattern, a foundational concept in object-oriented software design. Always use visual aids to illustrate the flow of commands between the client, invoker, command, and receiver for enhanced clarity. Demonstrate both implementations with and without undo/redo functionality to highlight the pattern's versatility and adaptability to different requirements. Extend the pattern to handle more complex scenarios, such as AI-controlled units, by having AI generate and execute commands. Discuss the pros and cons of using the command pattern in different situations to make informed design decisions for your projects. Explore how the command pattern can integrate seamlessly with Unity's new input system for modern and flexible game controls. Provide downloadable code examples for viewers to experiment with and apply the concepts directly in their own projects. Finally, consider the null object pattern for handling cases where a button might not have a command assigned, preventing null reference errors. Mastering the command